Continue with chapter 12 on circles. We're going to get into section 12.3 on inscribed angles. So an inscribed angle is an angle with the vertex on the circle. So this angle right here. So notice the vertex is not in the center of the circle, it's actually on the circle itself. And then the intercepted arc is this blue part right here. The arc that's intersected. So the first theorem in this unit, if an angle is inscribed in the circle, then its measure is half the measurements of the intersected arc. So let's say that this example up here, let's say this was 80 degrees. What would this have to be? 40 degrees. Easy enough. Well, let's say instead that this was 30 degrees. What would this be? 60 degrees. So we can go back and forth. Try example 1. Do A, B, and C, and then we'll go over that. Hector, what'd you get for A?
I got 74 for A.
Oh, Hector's right.
Let's go. Let's go, boys.
Jason, what'd you get for B?
I got 224.
224 is correct. Oski, what'd you get for C? 180. This is 90, so that's 180. Very good. Easy enough.
Let's go.
Now let's try these next ones. Try A, B, and C for example 2. All right, so if this is 110 right here, that arc, half of 110, 55. Let's go. Now we have a diameter. So it turns out that any inscribed arc or inscribed angle where the endpoints are the diameter, right? This has to be 180 degrees. What type of triangle is right here? A right triangle, and that has to be 90 degrees. All right, so let's check this one out. So AB is 72, right? So notice ACB. This guy is 72 degrees. So what's this? The measure of this one? 36 degrees, half of that. And then ADB. Oh, that should be up there. Notice that's the same intercepted arc. So what is ADB? 36. So two angles that intercept the same arc are in fact congruent. Question on that first section. So right here, corollary to theorem 1211. If two inscribed angles intercept the same arc, they're congruent to each other, just like example C says. All right. An inscribed polygon. So this is a polygon with vertices touching the circle. Right, so each of the vertices are touching the circle. So each vertex is on the circle. There you go. There you go. There you go. So if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. So whenever I have a right triangle, we know the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter, then it is a right triangle. Next, if a quadrilateral can be inscribed in a circle, if and only if its opposite angles are supplementary. So, it can only be inscribed if the opposite angles, F plus G equals 180, and E plus D equals 180. So opposite angles are supplementary. So let's go ahead and solve some of these. Try examples A and B, and then we'll do C together. Since this is a diameter here that goes through the center of the circle, this has to be 90. So x equals 90 degrees. And then since this is 40, the two non-right angles are complementary. So y simply equals 90 minus 40 degrees. Y is 50 degrees. So easy enough. For these ones, we know that opposite angles are supplementary. So x plus 100 equals 180. X therefore equals 80 degrees. And then 3y plus 120 equals 180. 3y equals 60. Y equals 20 degrees. This next one's a little bit tricky. Let's go ahead and set this up. 3x plus 3y equals 180. And then these guys, 5x plus 2y equal 180. So now I have two equations with two unknowns. We should be able to solve this using a system of equations. We can either use substitution or elimination. So let's go ahead and see what will work best for this one. So the first thing I'm going to do is see if I can simplify these equations at all. What can I take out of all three of these terms? 3. So let's get rid of this. So we have x plus y equals 60. I'm going to go ahead and put that right over here. So I have x plus y equals 60. And since many of us like elimination, let's go ahead and use elimination to solve. What can I multiply this bottom by to get the opposite of something? How about negative 2? So I get negative 2x minus 2y equals negative 120. And then I'm going to go ahead and add this bottom one, this blue one, to the top red one. So 5 plus negative 2 is 3x. Why we multiplied it by negative 2? Because the y term will disappear. And then 180 plus negative 120 is 60. Divide both sides by 3. X equals 20. And then to figure out what y is, just take that 20, plug it in right there. So we have 20 plus y equals 60. Y equals 40. We have x equals 20 and y equals 40. Last big idea for today. And this one tends to be the trickiest one. All right, here we go. If a tangent and a chord intersect at a point on a circle. So we remember, if a tangent and a radius intersect, then we have a right angle there. But if a tangent and a chord intersect at a point of the circle, then the measure of each angle formed is 1/2 the measure of the intersected arc. So let's look at this. Measure of angle 1 is half of arc AB. So if I have this measure, take half of it, I get angle 1. And the same thing with this one right here. Angle 2 is half the measure of that arc. So let's see how this works out. So if this is 150, what is the measure of angle X? 150 divided by 2. X is 75 degrees. If this angle here is 130 degrees, we want to figure out the measure of RSP. We're going to double this, right? So that's 130. This is 260 degrees. So the measure of arc RSP is 260 degrees. Now let's look at this last one. This last one's a little bit tricky. So angle ABC is 64. ADB is 4x plus 10. We want to go ahead and solve for x in this equation. So the first thing I can do is I can solve this a couple different ways. Can I find the measure of this arc here? Sure, I'm going to double 64. That's 128. So ADB, that arc measures 360 minus 128. So 4x plus 10 equals 360 minus 128. Go ahead and take a second and solve that. Again, x is 55.5. Questions on that?